As an example for how to use Compiler Explorer, we were looking at a for loop that sums the integers up to n, and we noticed Clang doesn't implement this as a loop. In fact, it uses this direct formula. But what's up with that? Accepting that our compiler can apparently do algebra now, why this formula? The real answer is probably that, well, it works, and this just happens to be what some general algorithm came up with. There's no reason to do it with a famous formula. But let's look at it a bit more closely anyway. How about this formula instead? Sum of the integers up to n equals half of n squared plus another half n. My first worry was about overflow with n squared as an intermediate step. We'll look at that in a second, but I think the real reason is much simpler. In Clang's formula, all intermediate values are integer. n minus 1 times n minus 2 is even, since one of the terms is even, so the quotient is fine. This formula breaks on odd n. Same holds for Gauss's n plus 1 times half n. Doesn't work for odd n if you use integers as you go. I mean, we could move the division all the way to the end, but now let's talk about overflow. N squared, as an intermediate value, is actually larger than the sum we are computing in the loop. If the actual sum overflows, this is a signed integer, so that's undefined behavior, and we can do whatever we want. But if the sum doesn't overflow, the generated code needs to be correct. So maybe n minus 1 times n minus 2 is just small enough to squeeze in? No, it overflows. Well, unless you have an even larger register. One of the things I told you not to look at originally would have shown you that our code takes a 32-bit argument, but has the intermediate result in a 64-bit register, and we don't overflow that. Okay, sure, but what if we take a 64-bit argument? Well, then Clang has a slightly different trick up its sleeve, and, well, this is where I give up. I think our trip down this particular rabbit hole has been fun and hopefully somewhat instructive, but let's leave it at this. If you do want to know more, the multiplication used to be an imul instruction, but now it's just mul. What's up with that? And this is shift left 63? More interestingly, there's a pretty cool blog post by Crystal Walfordson about why Clang is able to do this to loops, and why GCC doesn't, even though it probably could. Check the link in the description.